Hello and welcome to all the viewers. So in this video we will talk about how to create one-dimensional 3D model of topside module structure in ANSYS Spaceclaim direct model. We have created a similar video, a topside module modeling in ANSYS design modeler. But now, based on a request from the viewers, we're going to create a one-dimensional, that is a beam model in ANSYS Spaceclaim. So here, if you see, this schematic represents the topside model drawing. So here, the first one you can see, this is nothing but your top view, while this one is nothing but your front view, and while this is nothing but your side view. So with the help of these 2D drawings, we will going to create a 3D model. So here, like HE600A beam sections is used for all horizontal beam sections. So if you see the horizontal sections which are placed at the first deck as well as at the second deck, so all these are created with the help of HE600A. And now you can see RHS, that is rectangular hollow section 300 by 6 in tube sections, is used for all the vertical as well as inclined sections. So you can see all these verticals as well as inclined sections are created with the help of rectangular hollow sections. Okay, if we will try to zoom this, and now you can see that how it looks the 3D view. Okay, so like that we need to create an actual 3D model in ANSYS direct model. So before that, you just need to go to your workbench, and there you can just drag and drop your geometry system and then right click over there, and thus you need to edit your geometry in a Spaceclaim. Once you will click on a Spaceclaim, you will find that your Spaceclaim design window in front of you. Now let's start with the model. So before starting, you just need to look into furthermore in a dimensions, like we will going to create a 3D model of this 2D drawing. So before that, moving to the Spaceclaim, we should know that how to proceed. So let's see here in the first deck what we can do now. We will try to create this portion. We will try to create these intermediate lines, and then we will move to the second deck, and then we will create this overhanging portion. So let's move to the Spaceclaim. So here we know that the dimension is 8000 by 12,000. So basically we can subtract the 2000 from this 14,000. So we will going to create similar beam profile in our Spaceclaim. So let's go to the plan view. So very first we will create a line having a dimension of 12,000. Okay. Now right click over here and you can finish that line. So similarly repeat the process. So for that you just create the respective line. Here it is 8000, and then the next line, that is 12,000. Okay, so let's go to select. What we did now, we have created a line profile for the outer. Suppose if you will going to create, or you will going to connect these two lines, 2 points, then what will happen, these three curves. So when you create this fourth one, then there will be four lines are there. So once you will move to the 3D mode, you will find that instead of lines there will be the surface. So that's why we haven't created a closed loop. Now let's do the another thing. Just move this, select this plane, and here you can use the pattern. Press Ctrl button, you can move somewhat, and then you can define the count of 4, and then you can define the dimension, that is 12,000. Okay, so now you can see that 1, 2, 3 and 4th we have created a total 4 respective lines. Now let's move those respective line. Press Ctrl button and you can drag like that and you can put the 4000. Okay. Now furthermore, select all the plane and you can drag that to the topmost, as we know that here 4876 is the dimension, right? Now if you see, we have created this bottom deck, this is first floor and second floor deck. So there is only this extra overhanging 2000 portions we need to create now. So before that, we just click on the blend and we'll connect these respective points. So you just need to click the first point and then second point, press Ctrl button. So similarly repeat for all the respective points. Either you can repeat or you can even simply translate also. So here on the bottom you will find that whatever you have selected, like 2 curve points. Suppose if you have selected lines then it will not create a blend. So you just need to look into the selection. See here what we did, we first created first line and then we selected the third point. So here it is showing third point, so which is not needed. Okay, now we have created a box like structure. Just click on the home view. Now what we can do now, we can further connect these 2 points. Now let's go to select and then use a pull command for the fourth one. So use pull, then select on the direction, so you can give the direction and then you can drag this. Let's repeat further. Select the point, second point, third point, Control Z. So here you just need to go to pull. I think we did Control Z, that's why this point is missed. So let's do further, or you can use redo also. Just move out from this, it will create a confusion. Then click on the home view and then select your respective points. So now one curve and one point is selected, so we want all the points only. So here 3 curve points are selected and 4th curve point is selected. Now use pull command. So here you can use the direction, pull direction, you can give this one. I think it's not working, so what we can do now, we can select the first point first, we can give this and then we can drag that. Okay, so and then here you can put the dimension of 4. So similarly repeat for this point, give this direction and you can drag up to 4000. And then 4000. Okay, so this pool is totally depends on what you have selected. By default, if you have selected the line, then it will not create a proper pool. So let's move out of this and then create the blend option furthermore for all these respective point joining. So what we are doing now, we are connecting and we are creating the inclined portion of our members. Now you just select the remaining points and just finish. So now if you see that here you have selected a one curve point and one curve, that's why it's move to the surface creation. So what we need to do, we just click here and furthermore select first point, control, and then second point. So you just need to look into this whether we have selected points or curves. Okay, now you can see that your complete deck is ready. The next one, you just create furthermore blend between these 2 points, press this. Now let's repeat the process. Go to select, click on these 3 respective points, second one, third one, use pull, press Ctrl, and you can drag up to 2000 and then use the blend option. Select. Now you can see here your complete structure. If you click on here, you will find that your elevation, if you click on the Y, you will find that your top view, and if you click on the X, you will find that your side view is created, which is similar to this one. Now the next task is to create a beam section and then assign this to your respective structures. So let's move to click on the home, and then in order to create a section, you just go to prepare, and here you can see the profile section. So here, as we know that we have a two profile. First is RHS 300 by 16 and then rectangular, that is HE 600A. So if I will go further here, you will find that HE 600A and RHS 300 by 16. So here you just need to right click, edit beam profile, and here you can define the dimensions which is similar to 300 HE 600A. So I'm aware of that. So here basically I'm just putting that respective dimension. So here it is 300 300 and this is nothing but your 590 for a, and then enter. This is 590 for HE 600A. So I'm just putting all the dimensions which are similar to HE 600A. So if you Google, you will find that there is same respective dimensions, and this web is nothing but 30 mm. Okay, now if you look into this, you will find that this is 300 300 590 and this is 13, this is 25, this is 25. So this is top flange, this is bottom flange, this is middle flange. You will have a dimension. So once it is done, then go to your design, it will be automatically updated. Now the next task is create the another section, that is rectangular hollow sections. So furthermore, I think we created the beam sections, edit beam profile, and here you can define that is 300, enter, similarly 300, enter. So basically it is nothing but RHS 300 by 16. So likewise you can define the dimension for all respective beams. Okay, now let's go to the design and then click on the structure. Here you will find that your two beams profile, if you want to rename, you can define that, or if not needed, then just simply go to the curves. Then the next task is to create the beam section for this respective lines. So for that, here on the similarly on prepare panel, you will find the first option, that is create. So it's what it would do. It will create a beam along an edge, along an curve between the points, or points can be the vertices. So like that you can create. Once you will click on the create, you will find that your respective beams are created. Now the next task is to assign. Let's go to the select command. You have find that your all respective beams are created. Now the next task, go to the prepare, and if you see here on display solid beam, you will find that automatically it will HE600A are assigned to the all members. So what we need to do now, we can select, press Ctrl, select, and for all this we can define the dimension of rectangular. Okay, now if you look into zoom that, you will find that these are the hollow sections you can see here. Okay, now let's click on the Z further. Now what we can do now, we can select all these members. If you want, you can just put according to your preference. So now I will select all these members, or just do one thing, you can hide this. Okay, it got suppressed, we can do unsuppress that later on. Now select, and here you can assign the beam section. So now if you see here, it got assigned all the beam sections. So show all. Now you will find that these are vertical members, are tubes, while these horizontal members are beam sections. Now the next task is just to check whether all these sections are, let's change the color, and we can change color if you want. We can select this here. If you want, you can change the color. Right, now you can see the differences. Now if you see this horizontal beam, you will find that these are the beam alignment is needed for this respective beam. So what we need to do now, here also for all the horizontal beams, you will find that beam alignment is needed. So in that case, you just select all that beams. Okay, and just further look one more time on the top side, and here on the details view, you will find that here angle orientation we can define 90°, and you will find this angle is changed, and now it's become the vertical, or it is aligned to the other members. Okay, so likewise you can first create the curves, and then you can create the beam profiles, and then you can assign these respective beam profiles to the respective curves or lines, and then you can see whether all your beams are aligned properly or not. Okay, so I think we have created a complete sections which is more or less similar to our geometry. If you zoom here, you will find the sections which is similar to our Spaceclaim model. Okay, now let's click on this. Similarly, click on the Y. Okay, now let's see here our respective model is created. So as you know that we have created a complete 3D sections as per our drawings. The next step is that we need to move this geometry, or we can connect this geometry to the ANSYS mechanical for the simulation. So before that, you just need to look into your components, and you can have a look on that what are the respective beams which we have created. Similarly over here, so it is mandatory that you can either create a connections over here or you can create in a mechanical with the help of contacts. So what we can do, the most simpler way, which is similar to design modeler, you just need to right click, select all and right click furthermore, and here you will find the option called move to new component. So if you click on that, you will find that all these beams are created in a component. So this component is as similar to form a new parts. So like that, you will find that all these respective beams are present in a single component and which may have a connectivity with each other. Okay, so it is as similar to design modeler from a new component part. Now you will find the connectivity, so all the respective nodes which are at the connections will find the single node is created when you do the meshing. So no need to create a contacts in case of ANSYS mechanical. Okay, so that's it guys. We will see the next topic, that is simulations for the respective model. If you perform simulation at your end also, you will find that the connections for each and every respective nodes at the joint locations. So thank you guys, thank you, welcome, and let me know your comments. I will be there to help you.